Okay, so today we are going to review how to do single variable equations with decimals. In order for you to follow along, you should be putting the example that I do in your book. You're also going to be answering questions as you go along, just to ensure that you're understanding what's going on. So as I stop is when you should answer the questions. If you do not have time to answer the questions, just pause the video and then you can restart it when you're done answering the question. So when we're talking about single variable equations with decimals, we're talking about single variable equations that have variables with decimal coefficients. I want you to put on your paper what a coefficient is. What is a coefficient? Okay, now that you've done that, we can give a representation and do an example of what a decimal coefficient is. So I have 2x plus 5 minus 0.5x equals x minus 2.5x plus 17. Now, I don't see any distributive property or any parentheses that I need to do first. So I'm going to combine like terms. And before I do that, I'm going to identify the terms by putting a box around the variable terms. So one variable term is 2x. The term 2x is the variable term, not just the 2, not just the x. Another term is positive 5, and that's a constant term. So I'm going to underline it to show that it's different. And then here is my variable term that has decimals. So even though we do solve it in the same way we do integer terms, it's a little bit more trickier because it includes decimals. So that's why we're reviewing it. On the other side of the equation, I have an x term here. I want you to write what the coefficient in front of the x term is there on your paper. Okay, now my second variable term on this side is negative 2.5x. So I'm going to put a box around that. And I have one constant term on this side. So now that I've identified my different terms, my variable terms and my constant terms, I'm going to take each expression. This is one expression. This is the second expression. So the one on the left side, and work with it first. Never you do both expressions at the same time when you are combining like terms. So the two terms I can combine here I see are variable terms. I have 2x and negative 0.5x. So in order to combine those, I'm going to do just the same thing I would do with if it didn't have decimals. I'm going to take the coefficients and I'm going to combine them or add them together. So I have 2 plus a negative 0.5. And if I take 0.5 away from 2, I'm going to get 1.5. So my coefficient in front of my x term should be 1.5. Do not forget the x. Make sure that you're putting the x since you're combining x terms. So I have 1.5x. Now my constant term does not have anything to combine with. There are no other constants on this side. So I'm going to take and just put it down next to the 1.5x. So my expression should now look like 1.5x plus 5. More simple than the original expression. The next expression has x minus 2.5x. So these are two variable terms. So I'm going to combine those two variable terms. Just as I did before, I'm going to take the coefficients, and you should have seen that the coefficient in front of the x is 1, and I'm going to add the coefficients together to see what my new coefficient is. So I have 1 plus a negative 2.5. Now what I notice here is the negative 2.5 is a value further away from 0. So because it's a value that is larger, I'm going to know that my combined total is going to be a negative total. So 1 minus 2.5 is going to give me negative 1.5. Negative 1.5. And if I add 1.5 to 1, I get back to 2.5, so I know that I did it correctly. The 2.5 is a larger number, so I know that it's negative. So when I combine x and negative 2.5, I end up with negative 1.5 x, negative 1.5x. So after I combine those like terms, I see if there's any constant terms. There are no constant terms to combine, so I bring down my positive 17. And now I'm done with combining like terms. The next step is to isolate the variable. There are two options. I can do addition and subtraction, or addition property and subtraction property of equality first, or I can do multiplication and division, multiplication and division property of equality. Which one should I do first? I want you to write that down on your paper. Okay. It is easier and more efficient to do addition and subtraction first, so that's what I'm going to work with. So if I look on this side, I do have a positive 5. So in order to get this variable term alone, to isolate the variable term, I'm going to subtract that 5. When I subtract that 5, there's nothing to subtract that's a variable term, so that stays as 1.5x. And 5 minus 5 gives me 0, so there's no constants left on this side. So I bring that over and I have an equal sign. Now, because I want to maintain equality, because it's called the subtraction property of equality, I have to do the same operation on the other side. So I have to subtract 5 on this side as well. I put it under the constant term because it is a constant. It does not contain a variable. So I don't have a variable operation, so I'm going to bring my negative 1.5x down. When I subtract 5 from 17, I end up with positive 12, so I'm going to put my positive 12. Now I'm looking, I have all of the variable terms on this side isolated, but there's still a variable term on this side. So I want to make sure that this variable term is not on this side, but I have it on this side. So in order to do that, I only want constant terms on this side. I'm going to do the opposite, or the inverse operation here, and add 1.5x. Remember to put the x. If you do not put the x, your answer will be wrong. When I do that, I get 0 here and 12. So I'm going to bring my 12 down, put my equal sign, and now because it is the addition property of equality, I need to maintain equality, I do the same thing to the other side. I add 1.5x. When I add the 1.5x and the 1.5x, I get 3x. So now, again, with the decimals, I did the same thing I would have done if they were integers, but because they're decimals, they can seem a little bit more difficult. Now, once I'm finished with doing addition and subtraction, I move on to the division and multiplication property of equality. And remember, we always do the inverse operation. So I want to get this x alone. I have a coefficient here of 3. I want to get the x with a coefficient of 1. So what number can I divide? And I'm doing division because it's the inverse operation of multiplication. What number can I divide 3x by to get it to be 1x? Put that on your paper. Okay, you should have chosen that you divide it by 3, because 3x divided by 3 is going to give us x alone. Now, I cross these numbers out sometimes and people say cancel, even though that's not what it is, because 3 divided by 3 becomes 1. So it's not canceling because it does not become 0, but it becomes 1. So I have 1x. And now if I do it to one side, again, to maintain equality, because it is the division property of equality, I have to do it to the other. So I have x equals 12 divided by 3 gives me 4. And now I've gotten to my final answer, which is x equals 4. Now, you can go back and watch the video, but you should be doing your example problems after this to show if you understand what we just went through. If you're missing something, go back and watch the video again.